So a lot of section 1.2 I kind of hinted at in section 1.1 without maybe formally introducing the topics. So there's going to be a lot of overlap between sections 1.1 and 1.2. If I'm talking funny, well, that is what it is. I just got done running and it's like 48 degrees. It's a beautiful day. And sometimes when it gets cold and I'm outside, my mouth doesn't work. So sorry about that. Also, if the lectures seem awful, any of my lectures, just tell me that, hey, you can do a better job, and I'll reshoot the lecture. It doesn't hurt my feelings at all. I usually take the time to watch all my lectures after I record them, but I'm trying to get these lectures done on my Christmas break, and I kind of don't have time to do that. So if anything, find any mistakes or anything that just doesn't make sense, let me know, and I can redo anything. So in section 1.1, we talked about sets. And we said a set was a collection of objects. And we created sets. And in this section, we're going to more formally talk about the different ways to describe or define a set. And there's kind of three different ways to define a set. And they are with words, using a word description, using ugly set builder notation that you might have seen in an algebra course, because that's a real common algebraic way to define a set, and in roster form. You don't need to know what any of these words mean just yet. We'll go through and do some examples, and then you'll probably understand what the words mean, because they're not that complicated. A lot of what we do in chapter 1, in fact the whole class, there's nothing that's too complicated. So if I wanted to define a set using a word description, that's just using words to describe the elements of a set. The thing about word descriptions is there could be many correct ways to define a set using a word description. So when I write an answer to some of my problems in this section, if your answer doesn't have exactly the same words as mine when I ask you to write a word description for a set, that's completely fine, just as long as if your words describe the elements of the set appropriately, that's fine. A lot of times in this chapter we work with natural numbers, so just in case you forgot, between sections 1.1 and 1.2, the set of natural numbers is a set of numbers that are 1, 2, 3, 4, 5, ... and usually give the natural numbers the set n. That's kind of everything on the first page. So there's three ways to define a set with words, using set builder notation and roster form. We're going to talk about words first. Words are just literally writing a sentence or a sentence fragment that describes the elements of the set. There's many ways to write word descriptions that fit for the same set, and then the set of natural numbers is the numbers 1, 2, 3, 4, 5, and so forth. So let's do an example. My instructions here, I give you a set A. This set is actually in roster form. We haven't got to that yet, but roster form is one of the three ways to list to define a set. This set A is defined in roster form. Roster form is my favorite. It just lists the elements of the set. We're asked to write a word description for this set, and immediately when I look at this set, I can see that the numbers 1, 2, 3, 4, and 5, these are all natural numbers. So when I go to write a word description for this set, probably somewhere in my word description I'm going to use the word natural numbers, because every number in set A is a natural number. And I wrote two different word descriptions for this set. So this right here is word description number 1, that if I read it, I know this word description means the numbers 1, 2, 3, 4, and 5. So this is word description number 1. And I said set A, or A is the set. So I use the name of the set. I talk about the elements using the best words I can. So I started off saying A is a set of natural numbers. When I look at A, it has natural numbers, but it doesn't have all natural numbers. It has specific natural numbers. And then I decided to use the words between. And then I said 1 and 5. And then if I wanted to use the words 1 and 5, I have to put inclusive after. Remember, always when we use the word between, we usually list the smallest number and the largest number in the list. And so I listed between 1 and 5, and I used the word inclusive. Another way to write this, I could say Oh, how about this? I'll do this. I'll read this one, and I'll even do an answer 3. So this was one way back when I wrote this 3 or 4 years ago that I said this would be a nice way to do a word description of this set, because this means the numbers 1 through 5. This second word description is equivalently good. It's not any more or less correct. Number 1 is what I might naturally do. Description. Number 2, I said A is a set of natural numbers less than 6. And natural numbers are the numbers starting at 1 going up to infinity. Saying natural numbers less than 6, that doesn't count the 6, but it counts all the natural numbers less than 6, and those are the numbers 1, 2, 3, 4, and 5. Another way to say this, I could do an answer 3. I could say A is the set of natural numbers less than or equal to 5, or equal to 5. That also means numbers 1 through 5. So there isn't a right or wrong answer, but if you notice one commonality between all of my answers, in every one of my answers, I started off saying A is the set, and I use natural numbers. A is a set of natural numbers. A is a set of natural numbers. That part kind of needs to be there. You probably should have the name of the set in the word description. And because these are natural numbers, if I just said all numbers between 1 and 5 inclusive, that can include numbers like 2.5, and I don't want to include those. All right, so there's many, many correct answers, and you, when you're doing your homework problems, would only need to come up with one of the correct answers. Here's another example just to get us used to doing this. So write a word description for the set 4, 5, 6, 7, ... So this means 4, 5, 6, 7, 8, 9, 10. And this set goes on forever without ending. The ... dots tell me to continue that pattern. And since there isn't a number at the end of the ... dots, it means that list goes on forever. Immediately when I look at this, I know in my answer, if I'm asked to write a word description, I probably like to say A is the set, and then it's a set of numbers, and those are all natural numbers. So I started off saying A is a set of natural numbers. And then I needed to write something after that that only counts the natural numbers 4, 5, 6, 7, 8, 9, 10 and bigger. And then I chose first greater than or equal to 4, because this would include the 4. The or equal to part includes the 4, and the greater than includes every natural number greater than 4. So this would be the set 4, 5, 6, and 7. An alternate way to write this that is equally good is saying A is a set of natural numbers greater than 3, because greater than 3 doesn't include 3, but it only includes the natural numbers greater than 3, and 4 is the first natural number greater than 3. So both of these word descriptions would give me the set 4, 5, 6, 7. So let's do some homework examples. First homework example, I'll do question 2. You can do question 1. And I'm going to start off being real consistent with how I go to write these answers. So I'm going to say B is the set of, and I'm going to write natural numbers because all I see is natural numbers in my set. Oh gosh, my B is just like what I just did. I'm going to say greater than or equal to 4. It's natural numbers. I want to include the 4, so the or equal to part would include the 4. And then the greater than would include the 5, 6, 7, and so forth. So your question 1 should work real similarly. When I go to do my 4, you can do your 3. Usually when I have a list of natural numbers and I see the smallest and the largest number, I like to use the words between and inclusive in my answer. It's just kind of what I normally do. So this would be a way to answer question 4. I could say E is the set of natural numbers, because those numbers 5, 6, 7, 8, 9, and 10 are all natural numbers. And then I see a lowest number and a highest number. Let me put those after the word between. So I'm going to say between 5 and 10. And always when I use the word between in our class, after I write the numbers that something's going to be between, I have to use the words inclusive or exclusive. I'm going to use the word inclusive because I want to include the 5 and the 10. This would be the answer that I would instinctively write. It would be equally okay if I said E is the set of natural numbers between 4 and 11 exclusive. Because the natural numbers that I think of that are between 4 and 11 are 4, 5, 6, 7, 8, 9, 10, and 11. When I use the word exclusive, it doesn't count the first number mentioned, it doesn't count the last number mentioned, it only counts the numbers that are in the set 5 through 10. So these are equally okay. Because you only need one form of the answer, I almost never use the word exclusive in my answer, and I almost always use the word inclusive. Year 5, hopefully is easy, especially if you have younger brothers or kids or younger sisters. You need to come up with a word description so that somebody, when they read the definition of that set and the word description of that set, would understand what the set means. For my set B, these are all states that border the Pacific Ocean. I know Alaska and Hawaii kind of border the Pacific Ocean in some sense. So for me, I'm going to say B is the set, and I'll probably spell a word that I can't spell, of states in the continental U.S. That's the continental that I don't know if I could spell. That border the Pacific Ocean. I think that would be a reasonable description, assuming that my grammar is correct, and this to somebody that understands geography meant those 3 states. For yours, D is just the set of the 7 dwarfs, just in case you don't know who those are. Year 7 is easier than my 8. My 8's kind of a classic problem. 1 is equal to 1 squared. 4 is equal to 2 squared. 9 is equal to 3 squared. 16 is equal to 4 squares. My set T is the set of squares of natural numbers. I took every natural number, squared 5, I squared 6, and then I have ... which says the pattern continues. I'm going to say T in my word definition is the set of squares of natural numbers. I don't know if that's the best description, but I understand what that means, and hopefully everybody that would read this, that reads mathematics, would understand. T is the set of the squares of natural numbers. For your set A, E, I, O, and U, I'd probably, if you're thinking of an answer, I'd say it's the set of vowels. I guess I don't have the sometimes Y in there, but I think that I'm looking probably, when I wrote that, I intended you to say V is the set of vowels in the English alphabet or something of that nature. So at the beginning, I said there were 3 ways to describe sets or define sets. We just went through word descriptions, and now we're going to go to the ugliest one, which is the set builder form. So the set builder form is the second of 3 ways to describe or define a set, and this is a real formal definition. So set builder form says a set denoted in a formal set builder notation has 3 parts inside set braces. So when I use set builder form or set builder notation to define or describe a set, it has the curly braces or the set braces in the definition. So it has 3 parts inside set braces. The first part is a variable, which means some letter. It's usually a lowercase letter. I probably should have said usually it has the name of the set followed by an equal sign, and then to the right of that we get the set builder notation. The set builder notation has curly braces, and then the first thing inside these curly brackets or curly braces or set braces is a lowercase letter, often the letter X. And then it has either a vertical bar or a set for a vertical bar or a colon. 99.9999% of the time when I go to write something in set builder notation, I write the squiggly set braces, I write a lowercase letter 9 times out of 10, an X, and then 99.999% after that X, I put a vertical bar. So I have a set braces, a lowercase letter, a vertical bar, and then something that describes the set in symbols. So I'll say symbols to describe the set. And this is the hard part of set builder notation. How about symbols to describe the elements? And we won't get too crazy with these, but we need to have symbols after this to describe the elements. So this is what set builder notation in a really generic form looks like. On the next page, I have a couple of sets written in set builder notation. And just to get us used to reading set builder notation and getting us used to seeing a set in set builder notation and figuring out what elements are it's describing. So the first thing I've written here is an example of a set called set A. And immediately this set A is written in set builder notation. It has a lowercase letter. The letter X is often the lowercase letter that I use. A vertical bar, and then something after the vertical bar that describes the set. And this set is the set of all letters X, or all numbers X that are natural numbers. And this comma I'm going to read as an and. X is less than 3. So this set A is a set of natural numbers less than 3. So word description for this is A is the set of natural numbers less than 3. If I wanted to read this, I'd say A equals the set of all X with the property that X is a natural number less than 3, or X is a set, A is a set of all X's with the property that X is a natural number and X is less than 3. This is a absolutely fine way to write a set builder notation for a set, and I write beneath it written something that's equivalent. I took in this definition the words X is a natural number and I condensed them to the symbol X is an element of n. If I was reading this line or this line, I would read them exactly, well, I'd read them, they'd mean the same thing, I might not read them exactly the same way. This definition right here is another set builder notation. This says set A equals, I see the set braces, the set of all X with the property that X is an element of the set of natural numbers and X is less than 3. Both of these sets, if I wrote them in roster form, contain the numbers 1 and 2. Natural numbers start at 1 and natural numbers less than 3 are 1 and 2. So I wrote some more stuff. The curly braces are just the set braces. Those are just the set brackets we've been using quite a bit so far. The letter X is a variable. That's a variable, meaning it doesn't stand for just one number. It stands for a variety of values. In this case, it stands for the numbers 1 and 2. The vertical bar I was reading as with the property that, and then the comma means and. So I said I would read this as A equals a set of all values for x with the property that x is a natural number and x is less than 3. That's more or less what I said a few times, maybe not exactly what I said. We don't have to be able to read these precisely because there's a little flexibility in how we read these. We just need to be able to understand the elements that are in the set. And then, if I'm given a set like this, I need to be able to create a set builder form of that set. And that's a little bit trickier part. So on the next page, I started saying that's quite an involved description of the set. I translated the symbols directly to get the description. There are better ways to describe the set A. Here is a better word description for set A. A is a set of natural numbers that are less than 3. I like word descriptions much better than set builder notation, but I like roster form even better. And I already wrote the roster form for set A. The roster form for set A as A contains the elements 1 and 2. But all of these are exactly the same sets. The roster form for set A, a word description for set A, and a set builder notation for set A. Each one of these are equivalently correct ways to define A as a set. So any set can be written in 3 different ways. Any set, you can define it using words, you can define it using set builder form, you can define it using roster form. If you read mathematics texts, you'll almost only see sets described or defined in set builder form. Quite honestly, if I'm not reading a math text, you're not going to see set builder form that much. Word descriptions in roster form are more common in out of a math setting to define sets. Alright, so now I need to do an example, and I kind of split 2 pages. So I'm going to write my set in set builder notation. So my goal is to take this set, which is written in roster form, and my goal is to write this in set builder notation. And how do I write something in set builder notation? Well, I start by writing the name of the set, which is set A, and then an equal sign, and then I make my squiggly bracket. I usually make 2 of them. Sometimes I don't end the squiggly bracket because I don't know how big, or my set brace, I don't know how much writing I'm going to have, so I leave this and I put the end set brace in at the very end, just because I don't want to not have enough room. So to do something in set builder notation, you always start writing the name of the set and equal sign set braces, and then normally the lowercase letter x followed by a vertical bar. So this A is a set of all x with the property that, and then what I put after the vertical bar is the hard part. And what I put after the vertical bar has to represent all these numbers. And these are numbers that are natural numbers that are greater than or equal to 2. Because they're all natural numbers, they start at 2 and they get higher. Super easy for me to do this. I'm going to do this in the most efficient way that I can. I'm going to do it the lazy way. So I need 2 things after this vertical bar. I need to say x is a natural number and it's greater than or equal to 2. Easy to do that. In symbols, I could do it like this. I can say x is a natural number. That's the symbolic way to say x is a natural number. And then instead of writing the word and, I'm going to put a comma. And then after that comma, I'm going to write what natural numbers are. And these are the numbers that are greater than or equal to 2. And this would be a perfectly fine way to describe this set A using set builder notation. I do a couple, 2 or 3 other ways that I define this set using set builder notation, just to give you an idea that there isn't one correct way to take a set that's written in roster form and transform that into set builder notation. There's probably as many correct ways as there are students in our class, and so on the next page I write a few of those ways. So but they all kind of have a commonality. So here's another way to write that set A, which is 2, 3, 4, 5, 6, so 7, 8, 9, 10 forever. So I started off with the name of the set. I started with a small letter x and the vertical bar. All of my ways are going to have that. It's what I put after the vertical bar that just needs to describe the numbers 2, 3, 4, 5, and 6. And what I need is I need two things to the right of that vertical bar. I need to say something about x being a natural number, because I'm not having any decimals or fractions, and I need to only count the natural numbers that are 2 and bigger. And so I started off using the words for x as a natural number as opposed to the symbols, x as an element of natural numbers. Those mean the same things. And then instead of using the symbol for greater than or equal to, I use the words. I said x is greater than 1. And this would start with the number 2, because the first natural number that's greater than 1 is 2, and then we'd go on forever. This is just as good as the answer that I wrote on the last page. Let me go down and show you another correct answer. So another correct answer, again, you see this commonality. I start off with the name of the set brace, the letter x, and the vertical bar. A is a set of all x with the property that, and then after that I need two things. I need to say that x is a natural number either in words or using this symbol, and then I need to only count natural numbers that are 2 and bigger. And one way to do that is saying greater than 1, because that starts counting the 2, it doesn't count the 1. Another way in words to do that is say that x is greater than or equal to 2. This is equally correct. I wouldn't write either of these for my answer because they take a lot more ink to write. The third answer that I've written, this is the answer that I wrote on the last page. Again, I started off writing the name of the set A, the equal sign, the curly brackets, the x, the vertical bar, and then I need two things. I need x as a natural number, and I only need to count the numbers 2 and bigger. There's my symbolic way to say x is a natural number, which is a lot easier than writing those words. And this symbol, x is greater than or equal to 2, is an easier way than writing those words. I like writing symbols as opposed to words, but it's not wrong to write the words. And then the last way that I wrote it is kind of more equivalent to the top way. So I started off, A is the set of all x with the property that, I'll say x is a natural number, and x is greater than 1, doesn't include 1, so it starts with 2. All four of those all mean the set A, which is 2, 3, 4, 5, 6, 7, 8, 9, and ... forever. And there's probably other correct answers that I didn't come up with. So if I ask you to write an answer in set builder notation, and it's a homework question, and you get an answer and it doesn't look the same as my homework answer, that's completely understandable, because my homework answer probably only has one answer, and without doing too much thinking, I came up with 4 answers to this one simple set. Okay, this is an important problem because the between problems that we're about to get here are tricky for students. So it says write in set builder notation, A equals a set of natural numbers between 3 and 7 exclusive. So the natural numbers between 3 and 7 are 3, 4, 5, 6, and 7. The word inclusive means I don't count the 3 and I don't count the 7. I'm only counting the numbers 4, 5, and 6. Usually when we're doing a between for set builder notation, I will only, in the right hand side, when I start to do this, I will only use less than or equal to signs, and almost never do I use greater than or equal to signs in my set builder notation for between problems. So I need to come up with a set builder notation that means the set that contains the numbers 4, 5, and 6. So let me start to do that. I start doing the left-hand side. I write the name of the set, which is A, equals, and always in set builder notation, unless I have a real reason not to use the letter X, I write the letter X followed by a vertical bar. This says A equals a set of all X with the property that, and boom, I better say something about it's a natural number, because this is natural, X is natural numbers. So I do the lazy way. You can write the word X is a natural number, or you can write the symbols. So that you could have written, or I could have said A equals the set of all X such that X is a natural number. I like the shorthand way. And then after that, I can put a comma, or I could write the word and. and a comma for us are going to work equivalently. This is the easy part of this. So both of these tell me that x only contains natural numbers, so we're not going to have negative numbers, we're not going to have fractions, we're not going to have decimals. After the comma sign, or after the word and, I need to do something that describes the numbers 4, 5, and 6. And usually when we have the x's having a smallest and a lowest value, a smallest and a highest value, I put the smallest value first, the largest value last, and the variable in between those. And then I put less than signs if I don't want to include the numbers that I wrote. I put less than or equal to signs if I do want to include the numbers that I wrote. To me, I would say A is the set of all x with the property that x is a natural numbers and x is between 4 and 6, including 4 and 6, or x is greater than or equal to 4 and x is less than or equal to 6. Because this inequality right here, 4 is less than or equal to x is less than or equal to 6. This part right here says x is greater than or equal to 4. And then this part right here, when you put them next to each other, we're going to say it's and x is less than or equal to 6. So if you need x to be between a highest and a lowest value, you write x between those values. You put the lowest number first, the biggest number second. You put less than signs, and then you attach equal to if x is allowed to equal those numbers. Another way to write this, if I didn't want to use the or equal to sign, I could put the numbers 3 and 7. 3 is the first number listed, 7 is the last number listed. I could toss the x between those, and then I would choose less than signs without equal to. So I could say 3 is less than x is less than 7 in my set builder notation. And this would mean x is bigger than 3 and less than 7, but it doesn't include 3, so it includes the first natural number bigger than 3, which is 4. It doesn't include 7, it includes the last natural number that's less than 7, which is 6. So always on the betweens, we have to put the x between the two numbers, the highest and the lowest number, with less than signs. Equal to will include the numbers. Not equal to will include not include the numbers mentioned, but include the numbers that are next to those numbers. And on this next page here, this is just what I wrote right now. So these are the two answers that I think are fine. Again, I got a little bit lazy because I didn't use the words x is a natural number, but both of these are proper definitions for the set A. A is the set of all x with the property that x is a natural number and x is between 3 and 7. I would say this is between 3 and 7 exclusive, because you don't have the or equal to signs. So you think of that as an exclusive between. This definition right here says A is a set of all x with the property that x is a natural number and x is between 4 and 6. And when you put the equal to signs with those, I think of it as an inclusive. There are other ways to write correct set builder notations for this, but there aren't any better ways. So the between set builder notations can get really tricky. The first couple problems we get to do, 9 and 10, are they ask me to give this set, write it in set builder form. There are many correct answers. I like to do the lazy answer, so I'm going to do the laziest answer possible for number 10. So in set builder form, I'm going to write A equals the set of all x with the property that, those are all natural numbers, so I'm going to say x is a natural number and with a comma, and these are natural numbers. It's not a between, it goes from 3 forever. That's starting at 3 and getting bigger. Easiest way to say that is x is greater than or equal to 3. The alternative thing that I could have written right here, I could have written A equals the set of all x with the property that x is a natural number. If you don't want to write the shorthand symbol, I'm running out of room. And instead of the comma, I can write the word and then I could say and x is, I can say greater than or equal to 3 again, or I can say greater than 2. because greater than 2 without the or equal to sign starts at 3. And I close off my curly brackets. Those are both correct answers for number 10. There's other correct answers. So your 9 should work similarly. We'll move on to do 11 and 12. For 11 and 12, I'm going to use a between, which means it's a x in between two less than signs. So when I go to do number 12, I'm going to write my name of my set. B equals the set of all x with the property that x is a natural number, because those are only natural numbers, and with a comma, I'll say 1, x is between 1 and 6, and I always put less than signs when I use the betweens, and because I want to include the 1 and the 6, I do or equal to. So 1 is less than or equal to x, or x is greater than or equal to 1, and x is less than or equal to 6. There are other ways to write it, but almost always when I need to do a between, and I have a smallest and a lowest number, I write the smallest and the lowest number with the x between, and I use the or equal to. So there's no reason to do anything trickier. If I was doing your number 11, I would say A equals the set of all x with the property that x is a natural number, and 1 is less than or equal to x is less than or equal to 7 would be probably how I'd go about that answer. When we need to do 13 and 14, I give you word descriptions of the set. That's kind of useless. I need to figure out what elements are in my set before I can do a set builder notation. So P is a set of natural numbers between 4 and 9 inclusive. So P is going to have 4, 5, 6, 7, 8, and 9, and it includes the 4 and the 9 because of the word inclusive. So that's what the set P is. Now I'm going to write an answer for this in set builder notation. I'm going to say P equals the set of all x with the property that x is a natural number, and with a comma, I'm going to write 4, x, and 9. So I'm going to write the x between a 4 and a 9, and I'm going to include those numbers by putting or equal to symbols. And that would be the answer I would use for number 14. And when I go to write my keys, I'm very, very consistent when I write my keys. I get lazy. I never write the words x is a natural number, because that's a shorthand that means the same things. And when there's a smallest and a lowest number, I write that smallest and lowest number with the x between them, and I use the or equal to less thans. Always, always, always. That's how I do it. Although there's many ways you can do it, that's the way I do it every time. So let's look at 15 and 16. My 16, P is a set of natural numbers between 4 and 9 exclusive. Natural numbers between 4 and 9 are 4, 5, 6, 7, 8, and 9. But it says exclusive, so I'm not counting the 4 and I'm not counting the 9. My set P just has the numbers 5, 6, 7, and 8. Let me do my set builder notation. I'm going to write P equals the set of all x with the property that x is a natural number, and x is between 5 and 8. So I'm going to write a 5, an 8, the x between them, and to include the 5 and the 8, I put the or equal to signs. That for me is the easiest way to do a range of natural numbers in set builder notation. You just write the lowest and the highest number, the x between them with less than or equal to, it's right every time. So this was a word description. This is a set builder notation. We've done roster form, but not a lot of problems with roster form. This is the last thing we're going to need to do in this section. So roster is the third way. So we have set builder notation as a way to define a set. We have a word description as a way to define a set. Word description is the only one that doesn't really have symbols. It doesn't have the set braces in it. Set builder form has the set braces in it. And a roster form is a listing of all the elements in a set, and we use set braces for it. So let's get this going. Example, write the set in roster form. A is a set of natural numbers between 3 and 7 exclusive. So again, I see that word exclusive, so I'm not going to count the 3 and the 7 as a set. In the set. So set A doesn't have 3, it doesn't have 7, it just has the numbers 4, 5, and 6. So now I just need to list A in roster form, and that's my favorite way. How do I write something in roster form? I write the name of the set, followed by an equal sign, I write the set braces, and then I just write down every element in that set. And you can write them in an opposite order of me, but what's the point? I mean, just writing them from smallest to largest is fine. So A is the set 4, 5, 6. That would be considered listed in roster form. Sometimes I'll call it list form. It wouldn't be wrong if you said A is the set 5, 6, 4. When you're listing a set in roster form, as long as you have the elements correct, you don't need to write them in the same order as I do. So here's another example. Write the set in roster form. A is a set of natural numbers greater than 5. This is an infinite set because it's not between. There's only one number written, and it's a 5, and it's greater than. So it's numbers greater than, but not including 5. I'm going to need the ... in my answer because I can't write every number greater than 5. 5's not going to be in my answer because it's natural numbers greater than but not including 5. So for natural numbers, natural numbers start at 1, they go on forever. And in this set, I'm not counting the 1, 2, 3, and 4 because they're not greater than 5. I'm also not counting the 5 because it's not greater than 5, it's equal to 5. If this said greater than or equal to 5, I'd include the 5, but it doesn't. I'm only including the natural numbers greater than 5, which are 6, 7, 8, 9, 10, 11, 12, and so forth. When I went to write my answer, I wrote A, I wrote the set builder notation, and the least number of elements I can write down before establishing a pattern with a ... is 3. It certainly wouldn't be wrong if I said A is the set 6, 7, 8, 9, 10, 11, ... This means the same set as the set 6, 7, 8, ... The minimum number you're allowed to write is 3 to establish a pattern, but if you wrote 6 numbers to establish a pattern, that's fine. It's just more than you have to do. Here's a sneaky problem here, and we didn't quite get to something like this even when we did set builder notation, and this is written poorly. Let me change this to say D equals the set of all M such that M is a natural number and 4 is less than or equal to M is less than 8. This is not written so nicely. It's kind of not really set builder notation. It's something that's close to set builder notation, but it's not set builder notation. So let me write this in roster form. Immediately, this is written in set builder notation. I don't like it. But immediately, I'm looking to this part of the set builder notation. It says I'm only going to have natural numbers, and it's only going to have natural numbers between 4 and 8. The trick here is knowing when you have the or equal to, you include the number that it's next to, and when you don't have the or equal to, you don't include the number. So I see natural numbers and I see 4 and 8. So these are the numbers that I'm considering for the set, 4, 5, 6, 7, and 8, because those are the natural numbers between 4 and 8. I'm going to include the 4 because it has the or equal to. I'm not going to include the 8 because it doesn't have the or equal to next to it. So my set D is going to have the numbers 4, 5, 6, and 7 in it. And my answer for this is going to be the set 4, 5, 6, and 7. The next problem, when I blew it up, it kind of got wacky. So I'm going to say right here, B, I want to write this set in roster form. B is the set of all X with the property that, and then I didn't say anything about natural numbers. I just have a short description after the vertical bar. So I have to figure out what numbers are in set B. B is a set of all X with the property X plus 1 is equal to 9. Super easy to figure out what's in this set. There's only one number in this set, and the number in this set's the solution to this problem. I solve this problem by minusing 1 from both sides. The only number in this set is the number that makes X plus 1 equal to 9, and it's 8. And so when I wrote my answer, I said B is the set that contains the number 8. All right, now a bunch of homework problems. Asked to write our sets in roster form, and I give you either word descriptions or set builder notation. So when I look at problem 18, this is a set that's described in words. So the set A of even natural numbers between 5 and 10 inclusive. Let me work on my even natural numbers. My even natural numbers are 2, 4, 6, 8, 10, 12, 14, and so forth. I'm only looking at the even numbers between 5 and 10, so I'm not worried about any of these, because those numbers 2, 4, 12, and 14 aren't between 5 and 10. These are the only numbers that I'm considering for set A, and because I see the word inclusive, the end number 10 needs to be included. 5's not going to be included in my set because it's not even. My set A, written in roster form, which is my favorite, that's why I saved it for last, has the numbers 6, 8, and 10 as its elements. Your set is only looking for natural numbers between 5 and 10 inclusive. So when you're going down to list your possible elements of A, I'm only considering natural numbers, but I'm excluding every natural number because it doesn't say anything about odd or even. I think your set A is going to have all of those numbers. The word inclusive means you include the 5 and the 10. And your answer to 17 might be A equals the set 5, 6, 7, 8, 9, and 10. Usually when I see greater than or equal to's or greater thans, I probably am going to expect a ... in my answer. Let me try to figure out how to do number 20. A is a set of odd natural numbers greater than or equal to 5. So my odd natural numbers are 1, 3, 5, 7, 9, 11, 13, ... And which odd natural numbers I'm including? I'm not including 1 because that's not greater than or equal to 5. I'm not including 3. That's not greater than or equal to 5. I am including 5 because of the or equal to part, and I'm including 7, 9, 11, and 13 because of the greater than part. So my set A is going to start at 5 and go up by 2 to get all the odd numbers. My answer for problem A, problem 20, I'm going to say A equals the set, and then I'm going to go 5, 7, 9, 11, ... I could have just said 5, 7, 9, ... 3 is enough to establish a pattern. For your problem 19, you only want even numbers, natural numbers, that are greater than 4, and you're not going to include the 4 in your answer. So your first number in your set A is going to be 6. All right, my 22 wants a set of natural numbers greater than 5. Again, natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, ... For this set, I don't count the 1, 2, 3, and 4 because those are less than 5. They're not greater than 5. I also don't count the 5 because to count the 5, I'd have to say greater than or equal to 5. I'm only counting the natural numbers are greater than 5. And in my answer to 22, I'm going to say A is the set that has 6, 7, 8, and then ... Every natural number that's bigger than 8 will be part of my set because they're all greater than 5. 23 and 24 are tricky. Let me do both of these. The set of natural numbers less than 0. Well, if I look at my natural numbers, those are my natural numbers. They're all bigger than 0. There is no natural number that's less than 0. So I'm going to say A equals the empty set. There's no elements in set A. Another way to write my answer, I could use that symbol that we learned in the last chapter section for the empty set. Those are both correct answers. Your 23 is real similar. You're asked to, in roster form, write the set of natural numbers that are negative. There aren't any negative natural numbers. Your answer to 23 is going to be the same as my answer to 24. For 25 and 26, we have to figure out the elements in set B by solving the equation to the right of the vertical bar. In 26, B is a set of all x with the property that x minus 3 equal to 5. Let me just solve that equation to the right of that vertical bar. That's going to tell me the only element that's in the set. And I get 8 as my only element. So my answer to 26, B is the set that contains the number 8. 27 kind of spilled over. Let me just write it here so it's easier to read. So 27, C is a set of all m with the property that m is a natural number and m is less than 3. And my 28, which is similar to your 27, C is a set of all m with the property that m is a natural number and m is less than or equal to 3. So my C is going to only include natural numbers. It's going to include the 3 because of the or equal to. Your set isn't going to include the 3 because you don't have the or equal to. And then I want to include the natural numbers that are less than 3, which are 1 and 2. My set's going to have 1, 2, and 3 because these are all the natural numbers that are less than or equal to 3. 1 and 2 are the only natural numbers less than 3, and 3 is a number equal to 3. Your answer for 27 is going to be real similar, except you're not going to have 3 because you don't have the or equal to. Oh, these are bad problems. Let me rewrite this. 29 should say D equals the set of all m with the property that m is a natural number and 2 is less than m is less than 5. And my 30 should say D equals the set of all m with the property that m is a natural number and m is between 2 and 5, including the 2, not including the 5, I guess how I would think of that. When I go to write my answer for problem 30, I know I'm going to write D followed by an equal sign, and I'm only going to pick natural numbers, and at most I could put 2, 3, 4, and 5 in my set. I'm not going to include the 5 because it doesn't have an or equal to next to it, but I am going to include the 2. So the natural numbers between 2 and 5 are 2, 3, 4, and 5. When you have an or equal to, you include the number, and when you don't have an or equal to with that symbol, you don't include the number. So I include the 2 because of the or equal to. I don't include the 5 because of now or equal to with that inequality. My set D just has the numbers 2, 3, and 4. Last two problems. I don't know what happened to this, but your problem should say D equals the set of all m with the property that m is a natural number and 2 is less than m is less than or equal to 5. In my problem 32, it should be written D is the set of all m such that m is a natural number and 3 is less than m is less than 7. I'll fix these on my computer here in a minute. So when I go to write these in roster form for 32, I'm going to write D equals the natural numbers between 3 and 7 are 3, 4, 5, 6, and 7. Because the 3 doesn't have an or equal to, I don't count it. Because the 7 inequality doesn't have an or equal to, I don't count it. My set D is just going to be the numbers 4, 5, and 6. When you go to do your 31, it's going to be real similar. You just have to decide which of the natural numbers between 2 and 5 you're including. Alright, so that was a few minutes longer than the last video. Hopefully it wasn't too torturous.